This episode of Photonics Hot List is sponsored by Metal-Arc Optics, where they take on what others won't. Challenge accepted.
Hi, I'm Justine Murphy, Senior Editor of Laser Focus World. Let's take a look at some of the really cool things happening in photonics. Accurate and precise classification of recyclables is crucial for waste management optimization and proper reuse of materials. It's no small feat, but laser-induced breakdown spectroscopy, or LIBS, could help. LIBS is a technique used to detect and characterize materials by focusing a high-energy laser pulse onto the surface of a solid or liquid, or into gas or particles in the air. Using this technology, a team at Hefei University of Technology in China has achieved rapid and accurate identification and classification of recyclable waste automatically based on elemental compositions. Current processes are much less dependable, as they rely on just physical characteristics and images of materials. In their work, the researchers analyzed waste materials including paper, plastics, glass, metals, textiles, and wood. By later classifying these into subcategories, they were able to make more precise identifications of complex materials. And supplemented by machine learning models, the classification process reached 100% accuracy. With the ultimate goal of improving and promoting proper reuse of various resources, the researchers say they plan to increase the number of waste samples tested and expand the categories in which they fall. Photoexcitation annihilation. It sounds like a tagline for an action movie or a warning of apocalyptic times. It's neither actually, but it is something researchers have figured out how to handle. A team from Northwestern and Purdue universities has demonstrated that quantum interference can overcome the annihilation of photoexcitation, something that happens when a photon interacts with a material and its atoms change their quantum state. When molecules absorb photons, their electrons hit higher energy levels and bind together to create excitons, which carry the energy in the molecules. Migrating through a molecule network, the energy transfer of excitons is a key driver of chemical reactions in photosynthesis, as well as efficient energy harvesting in solar cells. The problem is, the excitons are known to destroy each other if they even attempt to come into contact. Using quantum interference, the researchers have found that low annihilation can coexist with high exciton concentrations. Traditionally, the high density causes high rates of annihilation, negatively affecting energy efficiency. The researchers say their approach could improve things like photovoltaics and be used in the development of quantum communications. Alone, thermal imaging and IR imaging, with challenges like generating vague imagery, each pose risks for robotics and autonomous technologies. Together, they could prove a force to be reckoned with. Researchers at Purdue University have combined the two techniques alongside machine learning to develop HADAR. This new approach, which stands for Heat-Assisted Detection and Ranging, can recover geometric textures in a weak scattered signal with thermal physics, machine learning, and spectral resolution in thermal images. A hyperspectral thermal imaging component can take images of a scene with hundreds of different colors in the thermal IR range, colors that are invisible to the human eye. Those images convey the temperature, material emissivity, and physics-driven texture of the scene. HADAR's machine learning element then disentangles the physics-driven texture from the temperature and material information. The researchers say this produces rich textures in the images obtained that are as vivid as those captured with daylight optical imaging. In addition to autonomous vehicles and robotics, HADAR technology shows potential for navigation devices, healthcare and wildlife monitoring, and defense applications. And that's your Photonics Hot List. Don't forget to like and share, subscribe to our YouTube channel for tons of great content, and visit laserfocusworld.com for the latest and coolest news and information. Until next time.